Okay, so what the first type of equation will be is when there's a log written on one side. So either side, you have the word log written one time in the problem, okay? And we'll compare it to the other two types here in a second. And what you do whenever you have a log, one single log on one side, is we write it in its other form. I mean, we have done this a lot of times. And when we solve this, you're going to see it's the same thing we solved. Oh, I know. The quiz we took on Friday where it said evaluate, you were just given something that looked like this. And then I said, whenever it says evaluate, you write equals X. You remember that? Now it's going to be written in there for you. And whenever that happened, we had to rewrite it in its other form. So we do 4 to the power of X equals 16. And we can get like bases on both sides. What would the base be that we can use for both 4 and 16? 4. You could make them both 2 as well, but why change something if you don't have to? So 4 to the x equals 4 squared. Come on, guys, pay attention. Raja, put your phone away. Come on, this is important. We have a quiz on Friday on this stuff. When the bases equal each other, the exponents equal each other. And that's it. So this problem is pretty much a review of ones that we've done before. Let me do another one. So you had problems on the last quiz that looked like this, and you had to remember to put equals x. It's already going to be written there for you on these problems. And we rewrite it in its other form. And we'll do a quiz review on Thursday as well. Okay, so 2 and 32, you can do 2. So I pick up my calculator and I figure out what power of base 2 will give me a 32. What is 5? 2 to the 5th is 32. So, whoops, that's an X, sorry. So when the bases equal each other, that means the exponents. Okay, so that's the first of 3 types. Okay. Question on the first type? All right. Second one is when logs written on both sides. So for example, you'll always be given the same base. It's not like I'm going to give you a log base 3 with a log base 7 or something. They'll always be the same. These might be the easiest of the 3 types, because the equation is balanced the way it is right now. Because log base 3 equals log base 3, you can cancel those out, and then you're just left with whatever left, right? X minus 8 equals 2x, and then you just solve the equation. We have x's on both sides. We need to get them together. So I'm going to subtract x from both sides. That leaves me with negative 8 equals x. Because 2x minus 1x is 1x, or just x. Right? Let's do another one of those. So start recognizing it. Log with base 4 on both sides. They cancel out, right? When you have some identical things on both sides, you can cancel them. That leaves me with just 2x minus 20 equals 6x minus 8. And now I just solve the equation, just like I would always solve this equation. So x's together leaves me with negative 20 equals 4x minus 8. And then what? Add 8. Negative 20 plus 8 is negative 12. And divide by 4. Okay. Give you a chance to catch up before we do our last type. So 2 types we've had so far. 1 log in the problem, log on both sides. Okay. So you might be thinking, well, what else could there be? How many more logs can we have? Well, yesterday we learned the properties of logs, and so sometimes you'll have more than 1 log on a side, and we have to put them together. So, the third type is more than 1 log on a side. So I'm going to write the problem, and then I'm going to review the properties with you. So this is what you missed yesterday. If you weren't here, remember there is a video in the notes. You should always, if you are absent, it is your responsibility to catch up. There were like 4 of you absent yesterday. So this is more than 1 log on a side. See how there's 2 logs on one side of the equal sign? That is the third and final type. So we need to remember the properties. So we had the first one, which was whenever we have addition, we can rewrite it as multiplication, or vice versa. Remember, if you're given addition on one side, you can rewrite it as the m and the, oops, that's an n, the m and the n multiplied. So we remember that multiplication and addition go together. One side of the equal sign is expanded, one is condensed, known as a single log. Okay. We also had the quotient property. Subtraction and division go together. So m minus, we write it as division, m divided by n. And there is one more. Let's just review it. I don't think we see it in any of these, though. And the final one was the power property. If you have a number with a power, we can rewrite it as a leading coefficient. We have to know these properties. Okay, so the quiz on Friday and the review on Thursday will be practicing your properties and then the 3 different types of equations, which I'm about to show you now. The third type. Okay? So this is what we learned yesterday. We did a bunch of examples. We did a worksheet, so if you weren't here yesterday and you didn't get it off the website, off of Canvas, see me and I will get you one. Okay, so notice we have multiple logs, or it's only going to be 2, I think. I don't think there'll be more than 2 on one side. So when you see that, you're going to use your properties to write it as a single log. So we know that when we see subtraction, we can rewrite this left-hand side as division. So we write our log and its base 1 time. See the log base 3 right there and there? And then we would have x minus 1 over, divided by 10, equals 1. So really, technically, I should put this in places, plus it looks neater. So that's the first step when you see more than one log on one of the sides. Now you say, okay, which type is it? Is it the type that we did, is it the first one we did on the other side or the second one? Look at it. Look at the other side of the equation. Right. So you should be able to look at this is the goal, maybe not yet, and see that there's only one log in the problem. So it's this type where you're going to rewrite it in its other form. Okay? So you're going to do 3 to the power of 1 equals all of that. Okay, we have to solve for x. Remember, even though you guys look at this as a fraction, think of it as division. This is x minus 1 divided by 10. The opposite of division is multiplication. So I'm going to multiply both sides by 10. So I get 30 equals x minus 1. Look how simple the equation just became, right? So those 10's canceled. 10 times 3 is 30. And then we would just add 1. One more. So I forgot to mention it, but I told you guys yesterday, you are going to have an open note quiz on Friday. I said quiz, I forgot to remind you that it's open note. So I hope you're taking good notes. You should anyway. But you're allowed to use yesterday's notes, today's notes, and your quiz review all on Friday. And that's your last grade of the quarter, Friday's quiz. Thursday, we also have a homework check, our last homework check of the quarter. So be ready for it. Okay, there's a lot of logs in here, but really look at what's going on one side. We have multiple logs on one side. That's when we use our properties, just like we did up here. We had multiple logs on the left-hand side. We used our properties. And we're going to do the same thing here. So whenever you see plus, we know we're going to rewrite this as multiplication. So I'm going to have negative 3x times 3. Remember, when you write as a single log, you only write log base whatever one time. So we see it twice, we write it once. Okay? And plus means multiplication for this guy and this guy. And then we haven't done anything to this side. Okay? Now what we have is either the first or the second type from the other page. The second. What tells you it's the second type? You have logs on both sides, right? You're either going to have a log on one side or a log on both sides. Those are the options. So you just have to know the difference. So when you have logs on both sides, we can cancel them. And you're left with just this, which I don't know why I didn't multiply that. That would be negative 9x. So let's see what our calculator gives us. 56 divided by negative 9. Not going to write that as a decimal. Math, enter, enter. Negative 56. Okay? All right, so you guys grabbed a worksheet when you're coming in. I'm only assigning the odds, okay? But of course, if you feel like you need more practice, you can do both, right? Let me grab it. I'm gonna do some. All right. Let's go to day 2, the day 2 side, not the day 3. Did you? All right. So break it down. So we're on day 2. 1 through 6, but you only have to do the first 3, the odds. That's log on one side. At the bottom, a log, single log on both sides. And then on the back, this is where you have to do your properties. Okay, I'll do one from each section, then I'll put the key up and come around. Okay? All right, so number 1, we have a single log on one side. That's when we rewrite it in its other form. That's a way of getting the word log out of there. Write it in its other form. 12 to the power of x equals 12. Bonus, the bases are already the same. What is x going to equal?
12.
No. What's this power here, JT?
2.
On the 12? What's the power on the 12? Help them out. 1. Right? That's 12 to the first. Right? So x equals 1. Yeah? That's okay. I love that you participate. Right? Stay with me. I'm going to do one of each. So we're still doing homework. Be okay with going out of order, my little perfectionists. Okay? By the way, when you see natural log, that ln, that means the same thing as log. Okay? Don't let it worry you. Okay? So if you want to change it to log, feel free. We'll talk more about natural logs another time. Okay, so log base 2, log base 2. On each side, think about the equation is balanced, so you can just cross them out. And you're left with just negative 3x minus 4 equals 3 minus 2x. And then we should have no problem solving from there. Right, Evan? So I'm going to do negative 2x plus 3x is 1x. Okay, so log on one side, log on both sides. Multiple logs on one side. So see how there's 2 on the left-hand side. Subtraction goes with division. So this is where we have to rewrite it in this other form, right? We can't cancel logs on both sides because we don't have logs on both sides. What is the base of a log, this log? 10. Remember, if you don't see a number there, if it's not written there, you should just know it's a 10. We've talked about that, right? Have we talked about that in this class? I must have. Okay. But if you don't see a base, it's 10, right? If you see a number there, it's that number, okay? So we're going to do 10 to the power of 2 equals that. Who said that? Okay, remember I just went over that? If you don't see a base written there, it's a 10. If you see a number there, it's that number. If there's none there, it's called a common log. Whenever there's no number, it's just defaults to a 10. Okay? So that's 10 squared. This is division, so I'm going to multiply both sides by 2. So I'm kind of combining 2 steps here. So 2 times 100 is 200. Right, that's 100. The 2's canceled on the right-hand side. Now, I'm just putting the answers up. This is not the work. So try them. If you're not getting the right answer and you can't figure out your mistake, call me over. I didn't write all the steps out because too many of us are just copying down my work and not doing it. So homework check, I will make sure I'm checking to see that you did the work too, guys, for whatever I checked. So we did 1 on